Now we come on to the types of algebraic expressions. There are basically 4 types of algebraic expressions: monomial, binomial, trinomial and multinomial. A monomial is an expression which contains only one term. Examples are given to you: 2x, 3y, 4p, 3yz upon 4. These are expressions which have only one term. Binomials are those algebraic expressions which contain two terms combined by plus or minus sign. Examples: x plus 3y, 4a minus 5c, ab minus c upon 3. Now in the first example, binomial x plus 3y, x is one term and plus 3y is another term. So two terms being added. 4a minus 5c. 4a is one term, 5c is another term joined by a minus sign. In this case, ab upon 3 is one term and minus c upon 3 is another term. Because this 3, we have taken 3 as the common denominator. We must have studied in unit classes also. When the denominator is same, the LCM also remains the same. Trinomial, as the word signifies, tri means 3. It contains 3 terms, and examples are given to you: x squared plus 3x minus 6, 3x plus 4 minus z. These are the examples of trinomials. Multinomials are those expressions which contain more than 3 terms. Then we come on to polynomials in one variable. A polynomial in one variable is a polynomial having a single variable. Example are given to you: 4x to the power of 4 plus 2x cube minus 3x plus 2. And as you must be noticing, I have underlined the variable. It contains only one variable, that is x. There is no other variable. Polynomial in two or more variables is a polynomial having more than one variable. Example are given to you: 5x square y minus 2y cube z plus z to the power of 4x square. If you see, notice it, I have taken 3 variables over here: x, y and z. So this is a polynomial in 2 or more variables is a polynomial which has more than one variable. Then come on to degree of a polynomial. The degree of a polynomial in one variable is the highest power or index of its variable. And if I take an example, x square, x to the power of 4 plus 6x square minus 5. I'm talking about the degree of a polynomial in one variable. Variable uses x only. And I said the degree of a polynomial in one variable is the highest power. If you compare the powers, this is 4, this is 2, the highest power is 4. So you can write, since highest power of the variable is 4, therefore the degree of x to the power of 4 plus 6x square minus 5 is equal to 4. The highest power is 4, therefore the degree will be also 4. Another example I take it: 2x cube plus 3x square plus 5x minus 1. The degree of this polynomial is 3. Now, you must pay attention how the powers are here. It's not x4, it's x to the power of 4 or x raised to the power of 4. 2x to the power of 3 or x to the power of 3. This means this can be expressed as 2 into x into x into x. The power of x is 3, not the whole expression. Only the power of x is 3, so x can be written as x into x into x. I only told you the power, when a number is raised to power, it is equal to the number multiplied by itself that many times that the power is. Is it clear? Now then we move on to degree of a polynomial. In two or more variables. And this is the sum of the exponents of the powers or the indices, sum of the powers of the variables in each term. Is taken and the highest term, highest power, highest sum is the degree of the polynomial, is the degree of the polynomial. Example I am taking 4m square n square minus 17 ln n square plus 8 l cube n square. Now the definition says sum of the powers of the variables in each term is taken and the highest term the degree of the polynomial. So sum of exponents, sum of powers in first term is equal to 2 plus 2. Why to the 2? Because m to the power of 2 and n to the power of 2, that will be 4. Sum of powers in second term, second term contains 3 variables and power of n is 1, power n is 1 and power n is 2, so is equal to 1 plus 1 plus 2, that is equal to 4. And the sum of powers in the third term is equal to 3 plus 2, that is n to the power of 3, power of n is 3 and power of n is 2, that will be 5. So the highest sum is 5. Therefore the degree of this expression will be equal to 5. Degree of this given polynomial will be equal to 5. Is that clear? Okay. Then polynomials can also be classified as linear polynomial, quadratic polynomial, cubic polynomial, and quartic polynomial. Now what are these? See, earlier we have classified polynomials as monomial, binomial, trinomial and multinomials. Another way of representing the polynomials is linear, quadratic, cubic and quartic polynomial. Now what is linear polynomial? Linear polynomial has the degree of 1. Any polynomial which has the degree of 1 is known as the linear polynomial. Example, x minus 2. Then quadratic polynomial, it has the degree of 2. Example, I can take x squared plus 2x plus 4. Over here the value is 1. In this case value is also 1 and the degree is 2. What is the degree of the polynomial? The highest power of the expression. And in this case, since the value is 1, the highest power of the value is 2. Therefore we take this degree as 2, and any polynomial which has a degree of 2 is known as the quadratic polynomial. And then cubic polynomial, it has a degree of 3. X cubed plus 2x squared plus 4, and the highest power of the variable is 3, therefore the degree of the polynomial is 3 and therefore known as the cubic polynomial. Now this, I've taken examples in which the variable is 1. Suppose there are two variables. I've taken another example, a cubed plus ab squared plus b cubed, and we have two variables a and b. Now, and what was the method to find the degree of the polynomial which has 2 or more than 2 terms or variables? We find out the degree of each term. The degree of this term, first term is 3, degree of second term is 1 plus 2, 3, and third term is also 3, therefore the degree is 3, therefore the degree of this given polynomial is 3, and that can be termed as a cubic polynomial. Quartic polynomial is a polynomial which has a degree of 4, which has a degree of 4. An example we can take as 4x to the power of 4 minus 5x cubed plus 2x squared. In this case the degree, highest degree is 4 and therefore it can be termed as a quartic polynomial. Is it clear? Now, then the operations, the 4 basic operations in algebra: addition, subtraction, multiplication, division. Addition and subtraction is always performed on like terms. Suppose you have to add 4x, 3x and minus 2x. These are like terms. For addition you use the plus sign, 4x plus 3x plus minus 2x. Open the brackets, 4x plus 3x plus and minus 2x. 4x plus 3x, 7x. How to do it? First add the numbers on numerical coefficients. 4 plus 3 is 7, minus 2 is 5, and copy down the literal, that is 5x is the answer. Suppose we have to add 25xy, 5x, 3x, 4y. So what we do is, first and what I told you earlier is you add or subtract the like terms. So which are the like terms in this expression? 5x and 3x. So it will be 25xy plus 8x plus 4y. And this will be your final answer. In no case, remember, in no case you can add 25xy, 8x and 4y, because these are unlike terms now. Is it clear? Similarly, I have used only monomials. This is addition of monomials. Suppose we have to subtract 4x from minus 3x. Now remember, in subtraction of algebra, the number after the word from will be written first. From minus 3x brackets minus y minus, we are going to subtract 4x. Open the brackets, minus 3x minus 4x. And if you remember, I told you earlier when we were doing integers, negative or the numbers with same signs are added, and the minus 3 minus 4 is minus 7, and put down the literal or the value. This is subtraction of like terms. This is, I've done addition of a monomial with another monomial, subtraction of a monomial by another monomial, and then multiplication of a monomial by another monomial. 3x multiplied by 7x. Do you know the tables? 3 sevens are 21. And when we are multiplying the like terms, so this will be x, the powers are added, and in this case, when there is no power, it is taken to be 1. The power is always taken to be 1. So it will be 1 plus 1, 2. In multiplication, the powers are added. Suppose, another example, we take minus 15xy multiplied by 5yz. 15 5s are 75. When numbers with different signs are multiplied, the product is always negative. I told you while we are doing integers, 15 5s are 75, minus 15 plus 5 is minus 75. Now, x will remain as it is. Y, the power of y is 1 over here, and then another term y is 1. Y plus 1, 1 plus 1 is 2, and z. This is your answer for this multiplication. Remember, when numbers with same power, same signs are multiplied, the product will be always positive. Numbers with different signs are multiplied, the product will be always positive. Now, multiplication of same signs, positive product. Multiplication of different signs, product will be negative. Is it clear? Then, division of a monomial by another monomial. Suppose we have to divide 75 x square y by 3x What we do, 75, divide 75 by 3, and in division, the powers are subtracted. And which powers are subtracted? Powers of the like terms are subtracted. X to the power of 2, over here the power is 1 to minus 1, and y square will be called, sorry, y will be called as it is. So it will be 3, 2 are 6, 3 5 are 15, that will be 25, and 2 minus 1 is 1. So x to the power 1 is written as x, and y this is